As per normal, I was doing some matrix shenanigans, and then I realized I overcomplicated certain things. But from given this, we're able to get these two to get this graph. Should be possible. A little painful, but it's possible. Another thing I will mention is about continuity, which is always something that all the every single time I have a midterm, there's something about continuity. In every single test, I have always had something about continuity. Um, where for in this case, I used it on spatial. So spatially, if you think of a object, it must be continuous unless it shatters or something like that. So it must be continuity is the way I solve this question. I wanted to put one question about continuity, so I made this question. So this question is important. Another question I made was a basic one that introduced everything, which is something like this. Um, the further you go down, the harder it gets. And then the last one was just supposed to be dumping a lot of basically just a bunch of calculus thrown at you to do. Basically, if you know calculus, you should be fine. I should probably put the ln here so we can do a little bit more about the ln linear, because it's fun to do, just because it's fun. And we get this graph, which is kind of complex, but in the end, it's very easy. It's just, oh, well, yeah, I should probably plug in the Hmm. I should probably plug in the what's the right word? The I forget the code for this because the code is actually pretty interesting. How you solve this code is completely different than what you would imagine the other ones because of all the continuities. It's actually easier to do it this way with the if then statement, which is interesting. I would not solve. I mean, this is what needs to be in here. As you can see, well, I need to put this over here like this, and then you just have to make it really small, like that. Yeah. I won't do it for all of them, honestly, because it's a pain in the ass to actually do all of them. Not joking, it does become a little bit of a pain to put all the code in. So I realized that it's not really a good idea to put all the code in just because I want to show it off, but realize the code for some of these things are long as hell, and this could be better off used for another space. A space could be used for something else. But I will put codes for certain things like this where I think the code is interesting. In this case, the code was interesting, which gave a credence to me putting it in there. But if there's a case where the code is not interesting and the same thing, we boring stuff again and again and again, I will not be doing it. Which is why I realized I deleted something over here where it was just, I think it was this equation right here. There was another code with another frame about the vectors, but I realized there's no need for that thing over there. I also did another deleted something over here where we had some. Was it for the curl? This one. I deleted a few things here because it was like, well, I could keep it, but there's no reason for me to keep that code. It was just a clutter at that point, or that graph. So I deleted some graphs here and there. Yeah, I think I didn't delete any of these graphs, but I deleted one of these graph over here. Above this, I think I deleted that graph. Which now thinking about it, I might have messed up because I don't think we have a graph for this negative y plus x. Oh, I might have messed up. I might have messed up. Unless we have negative y minus x. I mean, you could just look over here for that. So I don't think I messed up. It's very much the same thing here. So the new code is over here. So it should be all right. Oh, yeah, because you just changed the negative x to y. So yeah, I just kept the new code, not the old code. So this is pretty good, in my opinion. So that's what I've been doing. A few changes here. Oh, also, I did change a lot of things here to make it visually aesthetically pleasing. Um, in this case, I did a regular projectile motion and I split it to two pieces. You know this already. A lot of people know this because the first thing you get taught in physics. But this is how my brain visualizes such a situation like this. Um, So I visualize it as a splitting into x and y direction with time instead of a spatial component with this x and y with x increasing and y increasing. This is how I visualize it. I also visualize t for this case to be over here because you're starting t over here and time kind of is, you know, a it's not really starting here. It's like a spacious blob of the time is a physical like variable because we know that because a famous person did say that. Einstein said that. So and to say something similar, I forget what he actually said. But space is time is the absolute or something. No, time is not absolute. No, what was it again? I forget. Light is not absolute, time is absolute, right? Or was it the opposite, right? No, time is not. I forget something about that. I don't remember. I should probably read that again. Even though I'm aerospace, so that shouldn't matter unless I'm doing space mechanics, which I am. So I should really read up on that. Anyway, so frame the reference frame here is observer. We are doing basic Newtonian, which means 55 minus 45 is 5 meters per second. That's how fast that looks like. I realized I wanted a good visual for this, so I did a yellow car and a blue car with a man inside there, and I thought that would be a good visual. I had some kind of cartoonish shit in the past, which didn't really look good, so I decided we're going to upgrade that. And we're going to upgrade all this graphs into a MATLAB because we have MATLAB now. So why not use it for? I have MATLAB now, so why not use it for visualizing better? So I have started visualizing way better, and then started doing that. Um, yeah. So here's another case of me visualizing better and visualizing more. We're done with this topic, which means we're going to go on to finally projectile motion, aka with gravity being constant and the only thing that's accelerating. We'll talk about it because acceleration, constant gravity is interesting. It is one of the hallmarks of you learned physics, basically. If you know this topic, you're diving your head into physics. This is when you know that you're actually learning physics and not some bullshit. Um, this because this can be considered something like in trig or and then plus calculus, something you can get in a math class. Before that, but after that, there usually isn't a case where a math class does the thing in physics class does, because they want to split it for some reason, which is I'm fine with. But that's what I experienced, so that's why I'm saying it. Yeah, pretty good big changes here, man. Um, yeah.